Okay, so let's solve this question. The question states that consider the representation of number in base 3. Okay, the base has been given to us as 3 and the number itself is 210. Okay, what is the hexadecimal representation of the number? Hexadecimal means that the base of that number system is going to be 16. Okay, so we are given 210 base 3. We have to convert it into a number which is going to have a base 16, right? First of all, 3 raised to power of anything does not yield us 16 in any way, n being a natural number, that is, n belonging to natural numbers. If that is n belonging to natural numbers, then 3n is not going to yield us 16 in any way, right? So we cannot do chunking. For example, if the base would have been 2, then we could have taken 4 binary digits and then chunked that and produce a single 16 hexadecimal digit, and likewise we could have done that. That thing is not applicable over here because 3 is not going to 3 multiplied by itself any number of times is not going to give us 16 at all. Now if that is not possible, so how can we do that? So if something is difficult, try to bring that thing into a domain that is in which you are more convenient. That is just normal wisdom, right? So if I were to convert this into a number system where the base is 10, the normal number system which we all have played along from the nurseries classes, so first, second till 12th and then engineering whole, so bring it to 10 and then convert that number into 16, much more easier, right? So 210 in base 3 is going to have weights corresponding to the digits as follows: 3 raised to power of 0, 3 raised to power of 1, 3 raised to power of 2. Just multiply the weights to the digits that are present. You're going to get what? 2 times 3 square plus 1 times 3 raised to power 1 plus 0, because 0 times anything is 0 only. Okay, right? So this is 3 times 1, that is going to give us 3, plus 3 times square is 9, 9 times 2 is 18. That's not very clear. 18. This is going to give us 21. So 21 base 10 is basically going to come over here, right? That is what we got. That is the actual value of this 210 in base 3. Okay, now we can convert 21 into base 16 by means of the common method. You must have already seen this method at some point if you had studied number system dynamics. Digital logic basically comes under, so you must have studied this, right? So if you divide 21 by 16 multiple times and you write the quotient over here, you write the remainder over here, likewise, and you go on like this, like this, like this, like this, and then when you get a quotient which qualifies to be a remainder, right? Something when the quotient over here becomes smaller than 16, you read the numbers from in this order, and whatever number you get is going to be the answer. It is going to be the equivalent number in number system of the divisor, right? So this divisor is going to become the base of that number that you're going to get, right? This is the method that we all have studied, I do hope, right? So 16, if I divide 21 by 16, 16 times 2 is going to give us 32. So 32 is bigger than 21, right? So I cannot do that. So I'm going to put 1 over here. That is going to give us what? 16 minus 21 is going to give us 5, right? So that 5, now 1 is smaller than 16 by itself, so we cannot do that. So we cannot divide 1 by 16 one more time, right? So we can read it like this, and we're going to get the answer of what? 15 base 16 is equals to your 21 base 10, which because of the way we found out this is equals to your 210 base 3. And because this is exactly what we are trying to find in the start of the question, we can directly see which one of the options is 15. The first option is 15, and that is going to be your answer. It is a very simple 1-mark question. You must be clear on how number systems interact and how bases work and how some of these methods are used. You must have practice in them, and that's sort of the whole thing. I do hope that you learn something, and I will see you in the next video. Thank you.